In this video, I'm going to discuss electrical fields in conductors. Now, it's really common in when we start studying electricity and magnetism to use this idea of something called a conducting sphere. So a conducting sphere is essentially like a hollow metal ball, or it could even be a solid metal ball as well. Okay, and remember that something that's a good conductor is something that can allow electrons to move from one place to another. Okay, so in a conducting sphere, so inside the conducting sphere, an electric field is zero at any point. So the electric field inside a conducting sphere is always zero, no matter where you are. You could be here, 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 right in the middle, anywhere. The net electric field is equal to zero. Okay. Now we can imagine that this conducting sphere, like let's say it's a hollow conducting sphere, right? So this being the metal, and this being the inside. Okay. If I were to put like a positive charge, like right here on the inside, essentially what would happen is all the electrons would be attracted towards the surface, the interior surface, right? And then you'd be left with this like net positive charge over here, okay, on the outside. So what does that mean in terms of electric field? Inside, the electric field is still zero. Okay, just because the electrons have moved there, they're going to evenly distribute themselves, because remember, they repel each other. So they're going to repel each other, so they're all equidistant apart. Like they all have the same distance between every other electron. And then the protons in the positive charge would evenly distribute itself around the outside. Okay, so the electric field on the inside would always cancel out. But on the surface, so out here, like sort of in the world, there's going to be electric field as a result of the positive charge that this sphere now carries. Okay, so remember that electric field lines point away, and the electric field lines would point away perpendicular, to the sphere and on around the outside. Okay, but the main point to take home here is that in a conducting sphere, whether it's charged or not, anywhere inside there is zero electric field. Okay, but outside, the electric field is dependent on the distribution of the charge on the surface.